as we're kind of homing in on the value. So now I'm going to advance just a few more frames until the hand is no longer in a frozen state. And there, the hand is no longer frozen. So now I'm going to say not equal to previous value because the state of the hand changed. Goomba Patrol asked, does step mean frame advance? Step is not frame advance. Step is stepping through one line of code, and that's used for going through the game's assembly code, which we'll do later. So anyway, I'm setting this to not equal now because it was previously in a frozen state last time I did a scan. Now it is no longer in a frozen state. So I'll click on next scan. And now we have only 16 values left, so we're getting there. If we look at the values that are available to us, we see some that are just like 0, 1, 2, and 3, and we see others that are like 805B, 801C, 9034. The difference between these values is, and here's just a 240 here, the smaller values are usually values that are stored in memory, just like numerical values, and these large values point to memory addresses. So those are pointers, and the game refers to those when it needs to know like where something in memory is. But I'm not interested in these pointers. I'm assuming that the value that controls like the hand's frozen state is just a simple flag that's like on or off, or maybe like a state that the hand is in stored as a simple value. So I'm going to filter out all of these pointer states just by setting the scan to like less than 1000 or something in hex, and click next scan, and that'll filter out like everything that's like one of those pointers, so that filters down a little bit more. So anyway, I'm gonna keep filtering down a little bit. The hand is in an unfrozen state right now, so I'm going to advance a few more frames. The hand is still in an unfrozen state, so I'll say equal to the previous value. And it looks like it's having trouble narrowing it down anymore, so I'm going to try putting it back in the frozen state one more time. The hand actually, it has a few animation states, but I discovered previously that the hand's animation states are separate from what decides that whether or not the hand is frozen. So anyway, let me select a character, pause it immediately. So now the hand is in the frozen state, and I will say not equal to the previous value. And click on next scan. Okay, and you can see in doing that, some of these values, like we didn't narrow any more down, but we can see some of these values are a little bit crazy. We have some more pointers here, 90E6. We have a floating point, 3F80. So I'm going to say less than 1000 again, just to narrow it down a little bit. And now we only have like 3 left. So we can go one by one. This is enough where we can go just one by one through these memory addresses and figure out which one controls the memory freeze. I've done this before, so I know which one it is. So I'll save us the time of like doing trial and error, and I can tell you that this is the value. It's 814E. It shows 0 here, but that's a dolphin thing. It's actually 8. It's 814E 92E4. And we can verify that this is the hand freeze. And by the way, I'm going to go into Notepad and write this down, of course. Write down as much as possible when you're doing this stuff, because I've not taken enough notes and then I forget stuff. So like you want to label stuff too. Like I have some funny notes that are just like I took notes on like memory addresses and stuff. Like I'll show you one that I was doing with Sonic, if I have it here, hold on. Yeah, like these are some notes that I took for Sonic Adventure 2, and like I did this like a month ago, and I came back to it, and like this is like practically unintelligible. Like I have like jump to came out per frame, but like I'm just like, wait, what does this stuff mean? I have no idea what I was doing here. So you just want to make sure you take like really good notes so that if you come back to it later, like you actually understand what you're looking at. So anyway, aside the point, let's go back. So Alright. So I wrote down, here's our hand freeze address. So let's go back to Dolphin and we will test this out for ourselves. I have it nice and written down. So let's resume execution here. And I'm going to travel to this address, A14E92E4. And right now we can see that it's at 0. And I will select a character and I will pause the game right when I select the character. So the hand is frozen right now, and when I refresh this, you can see that it's set to 3. So what I'll do is I'll advance a few frames. The hand is still frozen, and it's still 3. And right now, the hand is unfrozen, and it changed back to 0. And normally when you'd be working on a code like this, you wouldn't know for certain that this controlled the hand freezing, but I can demonstrate it to you guys real quick by selecting a character and pausing the game. And this value is at 3. And I'm just going to manually set it to 0. Set it to 0. And now when I advance frames, I should be able to move the hand immediately because it's no longer in the frozen state. Chozo0 asks why it's 3 and not something like 1. I'm not the one who negotiated that. It had to do with either the coders of this game or the way that the code compiled into machine code. It's possible that this value uses other states or planned on using other states besides just the frozen one. But I honestly don't know. Sometimes this stuff is just like odd values. And you like it can take some time to figure stuff out. So anyway, so I just set this to 0. Although I just selected a character, I should be able to move my hand. Let me do this frame by frame. Let me advance a couple frames and I'll hold on the stick to see if I can move the hand. And I can move the hand right away. And so I just verified that this address that I changed is in fact the one that controls the hand freezing. So what I did was I used cheat search to search for an unknown value because I had no idea that this was between 0 and 3, and I was able to narrow it down to just a few until it's feasible to just go through them and figure out which one might control the hand freezing. And now I found an address, and now we can write a code. So let's go back to Notepad, and let's write our code. If you remember before, the code format that I'm using is 04, and this format says the 04 code means take the value specified at Y and write it to address X. So 423 asks, what if I assign the hand freeze to 2? I honestly don't know. I could experiment with it. It would probably do nothing interesting. It would either just not freeze the hand at all, or it would keep the hand frozen. The code might say, if it's anything besides 0, then the hand is frozen. And Linkshot actually pasted the code for me that I was going to write. So I'm going to type that in here. That would be 044E92E4, and then 0 because we're setting it to 0. But there is one issue with this code, actually. Our memory address starts at 81, and the 04 code assumes, because it cuts off the first 2 numbers, it assumes that it's 80. And so we need to specify that this is 81 and not 80. And there's a very easy way of doing this. I think I mentioned it before as well, but we can just change 04 to 05, and that specifies that our code starts at 81 and not 80. So this is our code. I'll copy this. Let me stop the emulator. And I will go into Brawl's config. And here are my gecko codes. So I'll put in disable hand freeze and paste my code. And as I mentioned before, put an empty line at the bottom of this file, otherwise it deletes your last line of code. I've I've written a code and it like freezes the game or doesn't work, and I get frustrated and confused as to why it was happening without realizing that Dolphin just like deleted my last line of code. And then the last thing is to enable this code, I put a plus here. So you can do that in Dolphin, but again, I'm working with a very small screen here, so it's difficult to demonstrate that in Dolphin, so I'm just doing it in a text file. I'll save, and we'll go back to Dolphin and load up Brawl. And let's see if the code works. And it looks like it did. My hand is no longer freezing when I select characters, and that also means I can spam characters like this. And like I said, this code was in Project M. I'm pretty sure it was in 2.1. Yeah, it's a nice code. Like, when I work on Project M, I like to focus on just like, I mean, not that I came up with this code. I'm pretty sure Standard Toaster did, but I like to work on things that are just general polish and things that like make the game feel better. You know, like I like to write something that's like any play instead of it being like a technical engine thing, like any player can like see this like cool new feature or this like aesthetic polish and be like, wow, cool. You know, like this project is really cool. That's the kind of stuff I like working on, and also the fact that Magus told me not to mess with the game engine. So this is kind of the stuff that I do for Project M. So if we want to, we can go into memory and we can like look at this address itself, but it's not very interesting. It's just 0 because we set it to 0. But now we have a code that has spammable characters on the character select screen. So, congratulations, this is a public code that is available to any Brawl users. Just put it in your code set. I will be going over that in this stream, but you can very easily look up how to do it. Oh, yeah, the codes that I'm writing, like, yeah, what Standard Toaster said is I only found player 1's hand state and not for all 4 players. So you'd have to go through and find this for all 4 players. Another issue is, this is especially true for the last code that we wrote that prevents player 2 from taking damage. Like the code, it worked in the circumstance that I showed you, but a lot of times these memory addresses that are negotiated by the game are set dynamically. So I could quit out and I could load like another stage, or I can load other characters or something, and it would, like, the memory address would just be stored in a different spot. And so in order to work with that, you either have to figure out like pointers that point to that memory address, and work from there, or you can actually go into the game's code and modify the line of code that like stores the value, and just like cancel out that line of code, or change it in some way. And that brings me to the next topic. So far we've done memory editing and we wrote codes that edit values in memory. But that's really only like a fraction of what's possible with this coding. We can write our own game code, our own machine code, and we can inject it into the game, or we can actually modify the game's lines of code to change the game's behavior in very new and interesting ways. And that sort of thing is very necessary for more complicated codes, such as a lot of the ones that are included in Project M, including the ones that I wrote. A lot of it is writing our own game code